Hello, welcome back to here, the channel where we'll be posting this. And this is my fourth take, if I'm being candid, because I'm just really terrible at explaining math, and I don't know why I chose it, but this is I think I've got it now. And also, I would like to begin by saying that I did some research, and by research, I mean I went on ChatGPT and I searched up what should I call my viewers for my biology channel. And it gives so many options, and one of the options was cellmates, which I thought was so fantastic. So from here on out, we are cellmates because biology, and you get it. But hope you like it. I love it. We're keeping it. So today we're going to be evaluating data, and I chose it because I feel like everything makes sense in the moment, but then after it's been like a week and it's time for the quiz or the test or the homework or whatever, I just like totally blank and like forget what all the steps were. So this is just, it'll be good to like increase my confidence when the time comes. But I've just written out the formula for standard deviation, so I thought maybe I just like could go through it along with a few other things. So I will make sure you can see this. So the S is, of course, for standard deviation, and then for a formula such as this, we're going to begin with this top half, and particularly what's in parentheses. So this Y just stands for the value of the sample. So we're going to get each value, and we are going to subtract each of them by the average of the whole. And once we get a number for each of those, we will then square it. So very important part of the process there. And once you've squared those values, you will then be able to add them all up. So this is just what this symbol here means, just to go ahead and add all of that. But you're not done yet. You still need to divide this new number by the sample size, but not just the sample size. It needs to be -1. So very key factor there. And once you've done that, then you can go ahead and square root the whole thing. You should be good from there. Next, we will look at the standard error of the mean. And this is just slightly different because we do need to already know our standard deviation, and that will be divided by the sample size square rooted. So no -1, just the square root of the sample size is what we will be dividing our standard deviation by. So there it is. And I have another definition that I've written to kind of like help understand just what the standard error of the mean is supposed to tell us. And that is just how our sample mean compares to a bigger population mean. And that's very important, especially if we have a small sample. And once we are graphing this information, it's super important to remember to multiply that number that we got for the SEM by 2. So that way we can have more accurate charts. Once we have our charts, we can then see if there's overlap in our error bars or not. And if there's not overlap, then that means that the data is significantly different, and that is valid. So that's a good thing. And the last thing we'll talk about is just the p-value. So p-value is the probability that something is random. So the p-value that is usually accepted is anything below or that is 5%. So 0.05 or 5% is acceptable, and that just means that that is a risk someone has accepted of how often they are okay with being wrong. So if they reject the null hypothesis, they will just be wrong about that 5% of the time. And that's all that we will be recapping today, but I hope this like little summary helped to just refreshing things. And thank you for watching. Like and subscribe.